This is our first shear example. For those of you in my class, this will be very similar to what's going to happen on your project. We're given a 20-foot center-to-center beam with support widths of 1 foot, 1.2 kip per foot dead, live 2 kips per foot, and we're using 4 KSI concrete and 60 KSI steel. First, you would do a flexure design, estimate the self-weight, get the MU, get MN required in inch kips, and then pick a row and an RN. These two are about halfway between row max and row min for 4 and 60. And once you know RN, BD squared required is MN required over RN. You need 5,700 cubic inches. Use, let's say D is 1.5B, we get B is 14 inches, put that back in, get D is 20.2, add 2.5, so we end up with 14 by 24. D is 21.5 inches approximately. Okay, subtract 2.5. We've gone over that. The actual self-weight is 0.35 kips per foot, not 0.3. So you update the moment, get MN required. Now you calculate the RN. It's a little less than 1.07. You get AS is row BD. You need 3.08 square inches. Choose 4 number 8s. And AS is 3.16 square inches. And it fits. A key thing to note here is that our row, we should go back and calculate the actual row, is going to be about 1.03%, 1.02%, definitely less than the 1.65% I mentioned earlier. So VC is going to be 2 square root F prime C B times D. Then we're going to approximate the shear envelope as I explained in the previous lecture. And so this right here is W U L over 2, and this is 1.6 W live L over 8. And you get this shear diagram, and then it's going to be at D from the face of the support. Okay, so D was 21.5 inches, but this is 6 inches here. So, and then another 21.5 inches. And so we're going to calculate the shear at 27.5 inches from the center of the support. That would be D from the face of the support. Okay, 7.5, so 2.29 feet. And so how did I get that number? You calculate this slope. So slope is 50.6 minus 8.0 divided by L over 2, which was 10 feet. Okay, so I'll do this. I skipped doing this in class. I'll do the numbers. That's 4.26 kips per foot. This distance here was 2.29 feet and delta V. So 4.26 equals rise over run. Delta V equals 9.76 kips, and 50.6 minus 9.76 equals 40.8 kips. That's how I got this number there. Okay, divide everything by 0.75, and so these are the new numbers. This is the maximum shear. And now we go to our shear design chart. We're gonna find these regions. So we need to calculate V sub C. Here we go. So 2 square root 4,000. B was 14 and D was 21.5. Okay. Let me double check that I did that. 2 4,000 square root 38,070 pounds, which is 38.1 kips. Okay, so let's go back and put these numbers in. So 50 BD, let's do this one. So that's 38,070 pounds plus 50 times 14 times 21.5. Okay. So 50, 14. This much is 15,050 when you add them together. 53,100. Some round off there. Okay, 53.2 kips. 3 VC is 114.3. So let me write these on the chart. 19.1. 53.1. And 3 VC 114.3. We are looking for those three numbers on this diagram. The highest is 54.5, so obviously we're not going above the 114.3. Okay. So the first thing we have to do is find this 19.1. Okay. So we're trying to find out how far from the middle of the beam is 19.1. So again, you use your slope, 67.5 minus 10.67, and the half length of the beam was 10. Okay, so 67.5, 10.67 divided by 10, 5.68. That should be the previous slope divided by 0.75. I was too lazy to go back. Okay, and so rise over run is the slope. So the rise is 19.1 minus 10.67. The run is delta x will equal 5.68. Okay, because we're looking at this triangle right here. Okay, and we're trying to figure out that run. And if you do that, delta x equals 19.1, subtract 10.67, and divide by 5.68, 1.48 feet. That's how I got that number there. Okay, so in here, no stirrups. The middle 3 feet of the beam will not have stirrups because this is half of the beam. Okay, no stirrups, no calculation. Region 2, okay. So out here, we're in region 2, and there might not be a region 3, as I'll explain in a little bit. Okay, so what we're gonna do, we did this one, now we're doing this one. This is the equation we're gonna use, okay. S equals AV FY over 50B, and we have to make sure that the spacing is less than D over 2. So region 2, okay. We're gonna try a number 3. AS for a number 3 is 0.11 square inches, but a stirrup has 2 legs, so AV is twice that, 0.22 square inches. So here we go, AV, FY. This has to be in PSI because the 50 is in PSI, and you get 18.9 inches, but it can't be bigger than D over 2. And D over 2 is 10.8. You have to round down, so we're gonna use number 3's at 10 inches. Okay, this equation here, okay, this equation here um, is based on the AV minimum, and that AV minimum is how we ended up with, if you remember the derivation, this is VC plus 50 BD. This is if you use 0.22 and 18.9 inches for AV and S. But we're not using 18.9. We're using 10 inches because the maximum spacing is D over 2. When you decrease the spacing, VS will go up. There's a good chance that when we decrease the spacing, the new VC plus VS will be bigger than our maximum here. Okay? If we're bigger than 54.5, we don't need a region 3. Okay, so let's recalculate the boundary. VS, remember, is AV FY D over S. Okay, so AV FY D. This is the real S, not the 18.9. If you put the 18.9 in there, nothing will change. So VS is 28.4, and the new boundary, when you use 10-inch spacing, you can use that all the way up to 66.5 kips. The maximum shear in our whole beam is 54.5. So that means you can use 10-inch spacing everywhere. Okay, and what we need to make sure is that when we do that, that this is the middle 3 feet. And so what I did, 10 spaces, how did I figure that out? What I did was from here to here, it had to be 10 feet minus the 6 inches of the support minus 1.5 feet. That was 1.5 feet. That was 0.5 feet. And so this distance here is 10 minus a half, that's 8 feet. Okay, and I need to divide 8 feet by 10-inch spacing. So 8 times 12 over 10 equals 9.6 spaces. Well, it has to be an integer, so 10 spaces. Note that there are 10 spaces, but 11 stirrups. Right, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the stirrups, let me put them in green. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, because there's one extra on the end, right? So we need 22 stirrups total. There you go. That's the end. And if you sketch it, you can't make a mistake. So please make a sketch to scale if you could. That's the end of this example. It's kind of boring because there was no region 3. We never got here. So I'm going to do another example where we get into region 3. That will be example 2.